we move ahead to the next module of stationary waves. In this module, students, we are going to learn about the derivation for equation of stationary waves. Remember students, this topic is a very important topic for board examination. It is asked as a derivation for 4 marks. So let us go ahead and see how do we derive the equation for stationary wave. For deriving this equation, we need to consider the analytical treatment of stationary wave, where we are going to analyze mathematically how do we obtain that equation. And for that, we need to physically consider a stationary wave. You can see the stationary wave which has N indicating nodes and A indicating antinodes. And as we all know, the distance between two nodes is lambda by 2, and between two antinode is also lambda by 2. And between a node and an antinode is given by lambda by 4. So we have two simple harmonic progressive wave with equal amplitude and equal frequency along a uniform string traveling in opposite direction to give us this stationary wave. We also know that they have a frequency which is given by n, wavelength which is given by lambda, and amplitude which is given by a. Now, I know that these waves are there, but before having a stationary wave, I need to consider individually progressive wave. Let me consider a wave which is traveling along the positive x-axis, which is shown by a uniform wave in the above diagram. The one which is traveling in the positive x-axis has the equation which is given by y1 is equal to a sine 2 pi in bracket nt minus x by lambda. Now students, this you must be wondering, where do we get this equation from? Students, we get this equation from the previous chapter, wave motion, the equation of a progressive wave. We also can say that the wave which is there along the negative x-axis, that is in the opposite direction, can be given by y2 which is equal to a sine 2 pi. Now since the direction is opposite, so the inner sign will be opposite. That means in the positive x-axis, the inner sign is nt minus x by lambda. In the negative x-axis, it will be nt plus x by lambda. So I have the equation of two progressive wave. Now students, we know from equation 1 and 2 that when we want a resultant wave as a stationary wave, this stationary wave will be obtained by the principle of superposition, according to which the resultant y is given by y2 plus y1, that is the vector sum of individual waves. We know the value of y2, so we can substitute that, as well as the value of y1. While substituting, I know that a can be taken as common, and inside it will be sine 2 pi nt plus x by lambda plus sine 2 pi nt minus x by lambda. Now I know that this inner part looks like a mathematical equation, that is sine c plus sine d, where sine c plus sine d is 2 sine c plus d by 2 cos c minus d by 2. And this, students, in the bracket looks like c. This in this bracket looks like d. So to get the answer, to get the solution, we need to find c plus d by 2 and c minus d by 2, so that we can easily substitute in the above equation. So let me take c plus d by 2. We know that upon 2 can be constant, so I write it as half and I keep it aside, and I take the value of c which we highlighted, that is 2 pi nt plus x by lambda plus 2 pi nt minus x by lambda. I know that x by lambda and x by lambda will get cancelled because they are of opposite sign. I'll get the final answer as half multiplied by 2 pi nt plus 2 pi nt, that is 4 pi nt. And when I divide it by half, the final answer comes out to be 2 pi nt. So that is c plus d by 2. In the similar way, we can also find what is c minus d by 2. Again, half is kept constant, and substituting the value of c minus d. When I solve this, I get 2 pi nt minus x by lambda minus 2 pi nt plus x by lambda. In this, nt and nt will get cancelled and the final answer will be c minus d by 2, that is half into minus 4 pi x by lambda, which eventually will be minus 2 pi x by lambda. So students, now since we have got the values of c plus d by 2 and c minus d by 2, we can use this again equation and get the final answer. We get the answer as a, which is common, 2 pi sine 2 pi nt into cos minus 2 pi x by lambda, but instead of minus 2 pi x by lambda, I am writing it as plus. Now you must be wondering why. It is because cos of minus theta is always written as cos theta. So this is how I get the final answer. Rearranging the equation, we get y is equal to 2a cos 2 pi x by lambda into sine 2 pi nt. And we can write the final equation as where 2a cos 2 pi x by lambda can be written as capital A, that is the resultant amplitude of the stationary wave, and y is equal to capital A sine 2 pi nt, where omega, let omega be 2 pi n. So final equation will become y is equal to a sine omega t. Putting the result in box, this is our equation for stationary wave. Thank you.